Hello students, how are you? Hope you must have enjoyed doing motion in straight line, and till now we have done questions using calculus, especially how to find out acceleration which changes with time. So this we had done already. Now the new topic that we are going to take up today is how to find out velocity. How to find out velocity when you have acceleration that changes with time. Mind it, non-uniform acceleration. You need to find out velocity when you know the expression in terms of time. You know the expression of acceleration, right? So let us take one very simple question. Suppose acceleration is equal to 3 by 2 t cube plus 5t, right, plus 2. If this is the acceleration, right, acceleration of a body is given by this. Find out velocity at t equals 2 seconds. At t equals 2 seconds. So we have to find out first of all the expression of velocity. How to do it? Expression of velocity in terms of time we will find out with the help of this, and the tool that we are going to use is integration. When we say integration, what is it? Let us quickly understand, because our aim is to solve this problem. In detail we will talk about what is integration and a whole lot of concepts behind that. Okay, so but today in the session we will keep it brief. We will just understand how that particular tool is applied and in what situation that tool is applied, right? The situation I had already told you. In this sort of situation, what you need to do is you need to integrate. When we say integrate, what do we say? What do we mean by that? Integration means summation of the small parts. While doing differentiation, we had found out the small parts, right? Where we had find out the small parts of the bigger function. Here what we will do, we will add up all the small parts. So that is the basic idea behind it. Let us quickly understand what integration is. Integration, and nothing much here you need to use. Just a simple formula that t raised to power n into dt gives us this, t raised to power n plus 1 divided by n plus 1. What is n here? N is the exponent. Okay, so this is what we need to use. This is the basic formula of integration. Basic formula. And what is it? Let us quickly understand. If you remember, while doing differentiation, we had to find out the slope at a given point. Slope at a given point. Here in integration, what we need to do? We need to find out within given range of time or whatever function it is, we have to find out the area under the slope. Integration is used to find out the area under the slope. Here we strictly focus on this one thing, that slope is not constant. When slope is not constant, then this tool is used, right? And that is the significance of this tool. Even when slope is not constant, we can find out the area of the slope. So this is going to be very interesting. Just focus and try to find out this thing. Suppose you have velocity time graph, right? And you have velocity time graph like this. Let's say it keeps on increasing in this manner, right? It keeps on increasing in this manner. And you need to find out the area under the slope. How would you find it out? You would find it out in this manner. From here, just have a look. This is T1, this is T2, and this is the shape. Now, is it easy to find out the area under the slope of this sort of slope? No, that is not easy, because we know area of rectangle, square, well-defined structure, that area, finding out that area would be easier, but this is not that easy. Here comes the use of this integration. So what actually we need to do is, this is the entire time period, T1 to T2. What we are doing actually, we will break this interval in very small intervals, multiple small intervals. Let's say infinite, consider it n number of small intervals, right? So let us quickly consider this to be dt. This strip, area of this strip, if we find it out, and this is taken as dt, this small portion. Now what? It appears to be one rectangle, one small rectangle. If we find out the area of this small rectangle, the strip you are able to see, what we will do? We will just add all such multiple strips within this range, right? Within this range of time, right? This is what we have taken. This is time actually, a velocity time graph. This is velocity time graph I have taken. So area under this slope. So area of this strip is added. So velocity at this, if you would find out this thickness of this, right? The thickness is, breadth is dt, length is v t raised to power n. Suppose this is t raised to power n, as I have taken here. So area is what? Area of rectangle is length into breadth. Similarly, what we have done, length into breadth. All such strips we are adding together. So integration means summation. Integration means summation. Adding up of all the smaller area of such strips within this limit, right? This is the idea behind integration. I hope you have understood this, and this is the basic formula. Okay, tell me one thing. If you have to find out, see, from 0 to T2, this distance, this time interval, right? From 0 to T1, this time interval. So if you need to find out this region only, this time interval, how would you get it? T2 minus T1 will give you this value. So this can be considered as lower limit, this is upper limit. So this is what we will do. Lower limit, this is upper limit. And after doing this, what we will find out? We will do upper limit minus lower limit. So this is the basic funda, right? This might be appearing to be a little complicated, but application is very easy, very easy. Okay, one more thing. Suppose Suppose you have got, this is one formula, this is second formula. Suppose you have got some constant only constant into dt, constant into dt. So what will you do? Constant into dt, c into t, this will come, okay, this will come as c into dt. C is here some constant, c into t, this is there, okay. 3. Next formula that you have to do is, if there is c into t raised to power n, this is sort of velocity into time, time is dt here for small strip. Now you are adding up all the small strips using this symbol, and the final result comes out to be, c is constant, so you will be taking it out, and then you have c into t raised to power n plus 1 upon n plus 1. So this is what we will use. So let us quickly understand how to use this. This is acceleration. Now, as you know, let us solve this. As you know, acceleration equals dv by dt. Acceleration equals dv by dt. So what can be done? This dv could be written as a into dt. dv could be written as a into dt. Now a into dt, a is not constant, a is changing with time. This is the expression for acceleration. You will put it here, and what you will do, this is the small, one portion, very small fraction of velocity, very small value of velocity. If you integrate, if you add up all those velocities, in integration we do that, so we will have this velocity. So the tool which we are going to use is integration. This is going to be a into dt, integration of this. And the limits are given as t1 to t2. We will talk about this. So this we need to understand. This is how the mathematical operation is actually represented. Okay, this is represented in this manner. We put the given situation to solve it in this particular fashion. Now what we will do? We will solve it. So let us do this. We have v equals, we need to find out velocity, that is a into dt, and integration of this. Now what is the value of integration? What is the value of a? What is the value of a? 3 by 2 t cube, 3 by 2 t cube plus 5t plus 2, right? So let us quickly do this. 3t by 2, 3t by 2, 3t cube plus 5t, right? 3t cube plus 5t plus 2. This is your question. Now let us do how to solve it. Let us see. dt. So very simple idea. Quickly what you need to do is, here limits are t1 equals 0, t2 equals 2 seconds. t2 equals 2 seconds. That was the question. t2 equals 2 seconds. So these are the limits. Within this limit we have to find it out. So first of all, what we will do, there are 3 factors, right? There are 3 terms. 1, 2 and this 3 terms, and this is multiplied by dt. So what we will do, we will individually find out the integration of this, right? So 3 t cube by 2 into dt, integration of this, plus 5t into dt, integration of this, plus 2 dt into integration of this, and all have got the limits 0 to 2, 0 to 2, 0 to 2. This is how we put it, right? Now applying that concept, as I have told you, the basic concept is t raised to power n into dt, integration of this will give us t raised to power n plus 1 upon n plus 1. If some constant value is given, that you can take out of this integration sign. Okay, one more thing is very important here, is that if you have got only dt written, so what you can consider is t raised to power 0 into dt, that exponent value would be 0 here. So formula would be this, t raised to power 0 plus 1 upon 0 plus 1. Ultimately you would find out this t. So this results in this, right? Integral of only dt would give value of t. So it is quite simple. No, you are adding small segments of small parts of time, adding together will give you that entire time interval, bigger time interval. That is what you are getting. So you are adding up. So keep that thing in mind. Okay, so here what we will do, we will put this constant out of this integration and symbol, and raised to power t raised to power 3. So what you will get, t raised to power 4 divided by 4. Why? Because formula is t raised to power n. N is exponent value. Exponent is 3 here. So n plus 1 divided by n plus 1. So this is the concept. I have taken the constant out of this. So what you are doing is, you are getting the integral of this and then multiplying with the constant. So you will get t raised to power 4 divided by 4. So this you got. Now here what? Here 5 t raised to power what? T raised to power 1. T raised to power 1. T raised to power 1 plus 1. 1 plus 1 upon this. So this will be 5 t square upon 2. What are the limits? Limits are 0 to 2. 0 to 2. Okay, here again 2 is constant, you will take it out of this. So 2 into t. So which comes out to 0 to 2. This is what you will get. Constant is taken out of this, out of integral symbol, and then only dt. I have explained it here. Only dt, how to look at it, how to find out the value. So this comes out to be only t. So this you got finally. Okay. After doing this, how to get the final answer? So next step would be v equals, you have 3 by 2. So you do one thing, 1 by 4 also you take out of this, right? So here you have 1 by 4 I have taken, t raised to power 4. Okay, so t raised to power 4, 0 to 2. When we say 0 to 2, what is the thing? You need to understand that these values are for this. This is variable and this is that value within which you are finding out the what? Finding out the area under the slope. So you have acceleration time graph. For acceleration time graph, and you are finding out, let us understand that, okay, this is the slope. You are finding out the area under the slope. When you are finding out the area under the slope, what you will do, this is let's say 0, this is 2, this is the value, right? So value of t would be 2 here, that we will put. Okay, then expression is, in the answer, 5 by 2 into t raised to power square, right? So this is 5 by 2 t square, and the limits would be 0 to 2, plus you have 2 t, and then you have 0 to 2. So final result would be, what we are going to do, 3 by 8 into, just have a look. First of all, we will put the upper limit. Here, how would you find out this? 2 minus 0. So this, in this manner we will do it. So put the value 2 here, whatever exponent is this, minus 0 raised to power 4. Okay, plus here 5 by 2, then 2 raised to power 2 minus 0 raised to power 2. Whatever exponent is there, that you need to keep in mind. Okay, plus 2 into upper limit minus lower limit. Value of t is first 2, 2 minus 0. So this is 2 minus 0, right? So quickly do this. This comes out to be 3 upon 8 into, what is this? 16 plus 5 by 2 into what? 4 plus 2 into 2 is 4. So this is there. So what you will get? 8 into 2, 8 2 ja 16, 2 2 ja 4. So what you will get? 6 plus 10 plus 4. What you will get? 20 meters per second. This is the velocity. This is our final answer. So this is the demonstration how the integration is used in this. Okay. In the next session, we will discuss more such formulas, right, of integration, and lot many numericals based on this particular tool, right. Till then, enjoy this, practice this. Okay, all the best. Thank you.